in this section, we're looking at expanding what we've done in the past from one-step equations, multi-step equations. Now we're looking at equations with variables on both sides. Of course, now, again, we're doing inequalities. So it's one-step inequalities, two-step inequalities, variables on both sides with inequalities. So it is very much like Chapter 2, the first half of Chapter 2, except now with an inequality. I'm going to do an example with you. I'm going to ask you to do maybe 3 or 4 questions on your own, and then I'll do another one with you with a story problem. So for this one, we're solving as if that was an equal sign in between. So instead of an inequality, if we just pretended that this was an equal sign, we're still going to solve it in the same way. We want to get all our m's together first, get all our variables together. Avoiding negatives is something I recommended before with an equal sign, and it was simply because negatives are one more thing to remember. Now it makes a much bigger difference, because if you get negatives and you start dividing with negatives, now you got to flip those signs around. So if you can avoid negatives, it will just make the problem easier for you, but it's not necessary. I am going to avoid negatives, however. So to get my m's together, I'm going to subtract 2m from both sides. 2m's minus 2m's, no more m's over there, that becomes 0. 4m's minus 2m's, we get 2m's minus 3. And now again, we're not with an equal sign, it's less than 6. Got to get all my non-m's together. So I'm going to add 3 to both sides. I get 2m is less than 9. Divide both sides by 2, and since I'm dividing by a positive 2, I can leave that symbol alone. And I get 9 halves, which is really the same as 4 1/2. Now I can graph it. Graph my solutions. There we go. And just I want to double check. Yep, I did that correctly. Good. I got 4.5 goes in the center of my graph. I'm going to go by ones this time. But you certainly don't have to. You can go by whatever scale you choose as long as you're consistent. Go 2.5, 3.5, 4.5, 5.5, 6.5. If m is less than 4.5, I know that 2.5 is less than 4.5. So my arrow is going to go that way. M will not equal 4.5, so I don't close in the circle. Try these 2 on your own. Try and solve them. Get x all by itself. Graph the solutions. I'm assuming you paused it. If you didn't, pause it. Don't just watch the answer. Actually try it first. If you've tried it on your own, I will say that once you have an answer, if you have this flipped around, if you have -2 is greater than or equal to x, that's the same thing. And so that's fine. It works. So if you see, as long as it's still eating the bigger number, as long as it's still eating -2 and pointing at x, you're good. Same thing here. If you have t is less than -1, great. If you have it the other way, where -1 is greater than t, as long as it's still pointing at t and eating -1, you've done it correctly. Otherwise, watch the linked video to see how it's done. Again, try these 2. We've expanded it. It's bigger, but it's still the same steps. Distribute to get rid of the parentheses, combine like terms, and see if you can't get k by itself and get x by itself. Pause it. Try these 2 on your own. Again, I'm assuming you paused it. I'm assuming you tried it on your own. The first one here, I have that -9 is greater than k. But again, remember, if you have that flipped around, if you said that k was less than -9, that's fine, as long as it's eating the -9. It's eating the bigger number, it's pointing at k. So make sure you have either one of those. Same thing for this one here. Make sure that you have x is less than 2, or it could be flipped around, 2 is greater than x. If you didn't get those answers, watch the linked video. Last one I am going to do with you here, we've got a word problem. I want to make sure that we're understanding how to take the algebra and apply it to a real-world situation, because that's really what's important. It's not just being able to do something on a worksheet, it's being able to apply it to a more real-world setup. So you got an advertising company, they charge a fee of $24 plus 10 cents per flyer to print and deliver flyers. So I've got $24 plus 10 cents. I'm going to use F for flyers. Print and More, what a great name. Print and More charges 25 cents per flyer and no flat rate. So 25 cents per flyer. For how many flyers is the cost of A+ advertising less than the cost of print and more? So blue was A+, red was cost of print and more. So I want to know, when is A+ advertising less? For how many flyers is it going to be less? I have my setup. Now I can use algebra to help me answer this question. So if I subtract 10F from both sides and get my F's together, which sounds bad, but I'm going to get my F's together, and I'm going to subtract and get 0.15 F's. Now I'm going to get my F's all by themselves. This is fun. And I'm going to divide by 0.15. And if I use my handy-dandy calculator to do 24 divided by 0.15, again, you can always do the arithmetic without a calculator, but at this point, we're applying what we know to a real-world situation. And in the real world, you'll have a calculator, most likely, accessible. So if I have more than 160 flyers, A+ will be cheaper. For how many flyers is the cost of A+ advertising less than the cost of print and more? If the number of flyers is greater than 160, if 160 flyers is less than F, then I'm going to have cheaper for A+ advertising. So F would have to be greater than 160 flyers. And that's how we answer those questions. So we're looking at the two different ones, applying that greater than or less than symbol there. So it isn't just one answer. It isn't if they did 161 flyers, it would be a better deal. Anything more than 160. Okay.